So in the la- okay, in the last class, we had discussed Young's theorem. So, did you have any problem in understanding Young's theorem?
No, sir.
Okay. So, I'll assume that the silence indicates that you are all wizards in.
So,
Yes.
so what did you teach in the last class? So I didn't go to the YouTube, so
Okay. What did I teach in the last class? Will someone kindly help me out? I think. I think I had discussed marginal product partial derivatives, first order partial derivatives, second order partial derivatives, and cross partial derivatives. Okay, so we have a function. Sorry, we have a function. Let us say x1, x2, x3. So this is the first. We call this partial first order derivative. Okay, so over here we assume that x3, x2, and x3 are constant. They are not changing. We can also derive cross partials for x2, x3. Okay. So in each case, this case for instance, we keep the other variables constant. So del x1 is equal to del x3 is equal to 0. There's no change in the other variables. Here also, the other variables are x1 and x2, so none of them are changing. This is the first order derivative. This is the second order derivative. Okay. And then we have cross derivatives. So there's a theorem which says that this. So which one you are taking first? Is del x1 into del x2 or del x2 into del x1? That is same. This is called Young's theorem. So I have stated Young's theorem and then I had discussed a very simple intuitive proof of Young's theorem. So if you check on the video, you'll be able to see it. And I think I've also given the references. So I had discussed the last class from Silberberg and Suen chapter 3.
yes, sir.
Okay. Now today I'm going to start by discussing a very important class of functions which are called homogeneous functions. Okay. So suppose we have a function we increase the values of all these variables by lambda. Not by lambda, sorry, it's a mistake, lambda times. So that means the variable takes the value of lambda x1, lambda x2, lambda x3, and so on. Okay. In that case, obviously y is going to increase. The question is how much will y increase? And the answer is that y will increase to if y increases by lambda to the power of n, then we say that y is a homogeneous function of degree n. Okay, is this clear? So let me give an example that suppose y is uh, let us say let us keep this, say y is equal to lambda k. Okay, then let us increase both labor and capital by lambda l and lambda k. So in that case, what is the new y now? Sorry. So instead of L, we put in lambda L. Instead of k, we put in lambda k. So this is simply lambda square into Lk or lambda square y. Okay, so in that case, this function y is homogeneous of degree. What is the degree of homogeneity?
2.
Yes. Y is homogeneous of degree 2. Okay. Now suppose we take y is equal to, sorry. Okay. What is the degree of homogeneity in this case?
So we can't have it. It's not a homogeneous function.
Yeah.
Yes, sir, it's not a homogeneous.
So this is not homogeneous. Y will increase, but the increase cannot be represented in this form. Okay. Now there are two very important theorems regarding homogeneous functions. But before coming to that, consider the Cobb-Douglas production function. What is the form of this Cobb-Douglas production function?
A L to the power alpha.
A.
L to the power alpha.
A into L alpha into K beta.
Okay. Now, normally, is this is this a homogeneous production function? Just check.
Yes, sir.
Yes, sir, it is an homogeneous production function.
So this is A and K beta, and this will be into lambda alpha plus beta. So what is the degree of homogeneity? It's alpha plus beta. And if alpha plus beta is equal to 1, then the order of homogeneity is 1. The degree of homogeneity is 1. We call it a linearly homogeneous production function. Okay. Now, there are two very important theorems, of which the Euler's theorem is perhaps the most important. The Euler's theorem states that suppose we have a function, suppose y is equal to f x1 to xn is homogeneous of degree n. Okay, so suppose it's homogeneous of degree n. In that case, xn into xn is equal to lambda y. So this is a very important theorem, and this has very important implications for production theory. We will also use this for in deriving certain results in consumer equilibrium. So let's look into this theorem and try to prove it. Okay. Now, one thing before pointing out, this is not an equality, it's an identity. That means this holds for all values of x. Now, by definition of homogeneity, we can write f of lambda x1 okay, this will be lambda n y. Okay, so if we differentiate this with respect to lambda, we are going to get this is just a first term, right? When lambda changes, how much does lambda x1 change? This will lead to a change in f. Similarly, for every term, we have and the last term is lambda xn is lambda n. Okay, so when we differentiate this, this will be lambda n minus 1 into y, right? Okay. Now, if we differentiate this, see, what is this? This is simply x1. This will be lambda x2. This is lambda xn. We have xn coming in. Okay. Now, see, we have differentiated an identity. Okay. So, in all cases, the identity remains. Now, let lambda is be equal to 1. In that case, we have simply del f by del x1. This will be del f by del x2. This is del f by del xn into xn, and if we put in 1 over here, this simply becomes n into y, what we have tried to prove. Sorry, sorry, এখানে আমি ভুল করেছি. Written the theorem wrong. This should be not lambda. It's a degree of homogeneity. So it should be n. Okay, is it clear, everyone?
Yes, sir.
Sir, can you show that slide also?
I'll show it to you. In fact, there's something which I also want to discuss. এইটা বলছিলে তো?
হ্যাঁ স্যার। স্যার completed writing.
হ্যাঁ,
Sir, can you please explain the second line, that how that df by d lambda x1 into d lambda x1 by d lambda has come
Wait,
from the
wait, wait,
first line?
wait. You mean this line or this line? This one.
Yes, sir. Yes, sir.
Okay. Think of it in this way. So we can write this function. So lambda x can be written as, let us say, z1. Right? When zi is lambda xi, right?
Yes, sir.
So in that case, what happens when xi changes? When xi changes, let us say x1, then this will lead to a change in z. This will lead to a change in f, right? Then I'm simply putting in over here, I'm putting in the value of z, which is lambda x1. So del x1, or rather del lambda x1 by del x1.
So that would be del L, del Z1 by del L.
Sorry. One ভুল হয়েছে। ঠিক আছে? So lambda changes. When lambda changes, z1 will change. This will lead to a change in f.
Okay, sir.
Okay. Now the question is that suppose we are taking a production function. Okay. In that case, how do we write this? And this is, let us say, homogeneous of degree n. So what is the Euler's theorem for this two variable production function? Del f by del l into l plus del f by del k into k. And this is equal to n into output. Okay. Now let us suppose n is equal to 1. It is a linearly homogeneous production function. Achha, but before that, what is del f by del l?
Say MPL.
So in case of the production function, it is simply mpl into l plus mpk into k. This is equal to nq. Okay. Now when the value of n, the degree of homogeneity is 1, then this is mpl plus mpk. This is equal to q. Okay. Now later on, when SM, I don't know whether SM has already taught it or not, you will see that this is the equilibrium. If the producer wants to see, the producer has to decide how much of labor and capital to use. So the optimizing condition for this is MPL is equal to W by P. And this is, for capital, it is R by P. P is the output price, and W and L are the W and R are the respective input prices. W is wage for labor, R is for capital. Okay. So if you substitute this over here, what do you get? W by P into L plus RP into K is equal to Q. So this is WL plus RK, and this is price into quantity. Okay. Now price into quantity is what?
Revenue.
Price into quantity is total revenue, as you have rightly said. And what is WL plus RK?
The total cost.
Right? So we can write this. So tell me, what is the profit?
0.
Right. So in case of a linearly homogeneous production function, so if the producer has a technology which results in a linearly homogeneous production function, and workers are paid according to their marginal productivity, the entire product is exhausted in meeting the wage and capital, the bill of labor and capital, as a result of which profit is equal to 0. Okay, this is called the product exhaustion theorem.
Sir, how do we get MPL equal to W by P? At equilibrium, we have MPL by MPK equal to W by R. So how is this formula derived?
In equilibrium, we have, what do we have?
MPL by MPK equal to W by R.
Acha. How do you get this condition? Right? We divide this to get this ratio.
Yes, sir.
Actually, the problem is that actually this is you will learn this in the next semester. This result.
So we get the point of tangency between isocost and isoquant.
I can't show it graphically. Graphically, I will get this condition, but if you solve the problem mathematically, you will see that the actual conditions are MPL is equal to lambda W, MPK is equal to lambda R, and then we divide the first equation by the second equation. Okay, so that the lambda cancels out. So I can show it mathematically, but then I will, it's a bit advanced at this stage, but I mean, SM will not be able to show it to you graphically. In the next second sem, MD will teach this, will cover this. So at this point, what you simply need to know is the product exhaustion theorem, which states that if workers and capital are paid the value of their marginal products the entire output is exhausted. Why? It gets distributed between labor and capital. Okay. Have you written it down?
Yes, sir.
Sir, 1 minute.
Yes, sir.
Yes, sir.
Okay. Okay. The second theorem is also somewhat similar. That if you have a function which is homogeneous of degree n, then the marginal product is homogeneous of degree n minus 1. So if you have a homogeneous homogeneous function, by the definition, we can write this, that we increase all the inputs, all the variables by lambda, y will increase by lambda to the power of n. Now this time we differentiate both sides by xi. Okay. So if we differentiate this by xi, so we take any x, let us say x1, and we differentiate both sides by xi. Okay, this will be, lambda will then become a constant, so lambda n del y by del xi, right? Over here, del xi changes, this leads to a change in del lambda xi, what we had called zi, and zi will lead to a change in f. Okay. Now, what is this? This is simply lambda. You can take out lambda. Lambda is a constant here. So what you have is del f by del lambda xi into lambda is equal to lambda to the power of n into marginal product. If you take the lambda over here, this is n minus 1. Right? Now, this is simply the marginal product evaluated at x, at a certain value x. This is the marginal product evaluated when we increase xi to lambda xi. Now, this is the definition of homogeneity of the marginal product function. What we are saying is that if you increase the value of xi, then the marginal product is going to go up by lambda to the power of n minus 1. Okay, is it clear?
Yes, sir.
Yes.
Uh, okay, over here, what I heard was that you have not started price consumption and income consumption curves, right? Okay, but you know what income elasticity is. You know what an income demand curve is, and you know what the income elasticity is, right? Am I right?
Yes, sir.
Okay. So, okay. So generally we write the the demand function as a function of own price, the price of complements, price of substitutes, income, taste preferences, and other factors. Now we are interested in these commodities. We just take a shorthand. This is own price. Complements and substitutes are grouped together as price of related goods and income. And all other commodities are Z, which we assume to be constant. Okay. Now, if we also hold PR and that is price of complements, substitutes, and income to be constant, if PR and M are constant, the demand function simply becomes a function of own price. This is the own price demand. And similarly, if we hold the own price and income constant, we get what is called, what is this demand curve called? This is called cross price demand curve. And if prices are held constant, we get the income demand curve. Okay. So we can define the income elasticity as minus dx by dm. Actually, it should be partial m into x. Sorry, just wrote minus by carelessly. So this is the what we call the income elasticity of demand. And if you want to draw the income demand curve, then income demand curve is what will be the slope of the income demand curve? Am I right?
Yes, sir.
So if it is a normal good, then when income will increase, quantity of X will also increase. Sir, are you saying something? We can't hear you.
Hear me now? Can you hear me now?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay. So I'm asking that what is the income formula for income elasticity?
Del x by del m dot m by x
Del x
by del m dot m by x.
m by x. Okay. Now over here, what? See, this is the tangent. What is the tangent over here at point C? What is the? This is the change in x. So what is the change in x? We just have to take this line AD, ACD. What is del x? Can you hear me?
Yes, sir.
Yeah. So what is del x over here? First tell me what is del m.
AB.
Yeah. Del x is AB.
Del m is BC.
It is BC. Now what is m?
C and something.
It is still CB. At this
Yes,
level,
sir.
what is your income? Sorry. I made a mistake. I don't know why I'm making this mistake again. Sorry, this is x and this is m. Okay, so del x is CB. This is del x and this is change in income. AB. Now, what is m? M is 0 to B,
OB.
OB.
Yes, sir.
And what is x? X is simply this part which is equal to BC. Or that I'll write CB. So in that case, what do we have? We have OB by AB. Now, which is larger?
OB.
Sir, OB.
Okay. So if A is to the right of the origin, OB is greater than AB. What will be the income elasticity?
Say greater than 1.
Okay. Now, suppose I'm taking. Wait, let me. Oh, So now I better draw this again. So I'm taking two demand curves over here. It's very difficult to draw it in together. Okay, so if we ভুল হয়ে গেছে এইখান দিয়ে ড্র এটা যাবে আচ্ছা এইটি দিয়ে আগে করে নি it will be faster. Okay, so this is B, this is C, and this is A. Okay. So here we can see that A is to the left of the origin. In that case, which is larger, OB or AB?
AB.
And income elasticity will be
Less than
1. Now suppose we have a curve like this. So I'm drawing over here. Okay, I'll call this B prime.
Sir, here income elasticity will be equal to 1 because
Yeah.
AB is equal to
Here A is on the origin. So OB is equal to AB, and which implies that income elasticity is equal to 1. Okay, is this clear, everyone?
Yes, sir.
Okay. Now this is the budget line, m equal to p1 x1 plus p2 x2. Okay, p1 is, let us say, constant. Okay, so if we differentiate, how does expenditure change?
P1 dx1.
আচ্ছা, এইবারে Suppose we want to bring the income elasticity formula over here. Okay, so I've got del x1 by del m. So I have to bring over here m into x1. So that means I have to multiply by x1 and divide by m. Right. So in this way, okay. So this is P1x1 by m into income elasticity for the first commodity. And this is income elasticity of the second commodity. Okay, now what is P1x1 by m? This is simply the share of expenditure on the ith commodity. Right? So now you have got a very simple statement, simple formula for two commodities. You can obviously extend this to n commodities also. 3 commodities, 4 commodities, whatever. So in the general form, you can write this in this way. That is the weighted sum of income elasticity is equal to 1. When the weights are the share of expenditure on each commodity. Is this clear? Have you done these theorems, by the way?
Sir, in demand did this part, this last thing.
Achha. So we'll have to find a theorem which MD hasn't covered. Okay, this theorem, I think she's also covered this.
No.
Okay, but before coming to that theorem, I have to prove something else. The demand function is homogeneous of degree 0 in prices and income. See, we have a demand function. Let us say that it's a two commodity world. So demand is a function of P1, P2 and M. Okay, now how do we get this? So this is the budget line given by AB, and his equation is M equal to P1x1. So we have the, let us say some utility U1. So this is the amount of x2 that you will consume, and this is the amount of x1 that you are going to consume. This is the equilibrium, right? Now suppose price doubles. So P1 and P2 both increases by, let us say, lambda. How will the budget line change?
So it will rotate. So it will shift.
If only one price changes, then you will have a rotation. If both prices increase or decrease, then it's going to be an inward or outward shift. It will be a parallel shift of the budget line. Okay, it's going to be like this. Since prices have gone up, budget line is going to come here. If prices decrease, budget line will shift outwards. It will be something like this. Okay, now suppose your income increases by lambda. Okay, so prices are constant, but income has gone up by lambda. What will happen to the budget line?
So it will shift outward.
So again, it will be a parallel shift, right? Now suppose both occurs. Suppose prices and income both increases by lambda. What will happen to AB?
So there will be no change because lambda will cancel.
So AB will remain the same. You can see that all of them has increased. So M is still P1 x1 plus P2 x2. So if the budget line doesn't change, will the equilibrium point change? What will happen to the equilibrium?
So it will not change if AB remains same.
So equilibrium will remain at point E, and demand is still x1 star and x2 star. Okay, now come back to the demand function. See, what is the demand for x1? It is a function of P1, P2 and M. When we have increased all of them by lambda, how much has demand changed?
So it will remain the same because equilibrium is same.
It is still x1. So what is the power of lambda?
0.
0.
Lambda is 0. So this implies that the demand function is homogeneous of degree
0.
0 in prices and income. Right? So x1 is a function of p1, p2 and m is homogeneous of degree 0. Now, what does Euler's theorem say? If you have a function like this, del f by del x1 into x1. Okay. So what is x1 over here in case of the demand function?
So P1,
It is p1. What is x2?
P2,
And what is n?
0.
It is 0. So by Euler's theorem, we have del f by p1 into p1 del f p2 into p2 del f del m into m. This is equal to what?
0.
This is equal to 0. Okay. Now suppose we want to bring in elasticity over here. What do we have to do?
So we will divide by x1.
And multiply by x1. This is p2, so it is x1 by x1. This is so x1 is common, right? What is this expression? This is price elasticity, E1. This is E2. And this is income elasticity. And it is equal to 0. So x1 becomes 0. x1 cannot be 0. Therefore, this has to be equal to 0. So what we are basically seeing is the sum of own price, cross price, and income elasticities is equal to 0. So suppose I tell you the value of E2 and EM. Can you find out E1? Suppose E2 is 2 and EM is 3. What is the value of E1?
-1.
It is -5. Now tell me one thing, what are substitutes and complements?
So what?
The
What are
substitutes are those
substitutes?
goods for which if the
Substitutes
price of
are
one good increases, we consume the other good.
Sir, when the price of complement goods increases, the price of other complement good also increases.
And for
The demand,
substitutes,
the demand.
goods. In price of
Okay,
one good increases,
can you give the best example of complementary goods?
car and petrol.
car and petrol.
Sir, hardware and
Are-
software.
Hardware and software, very interesting. But the best example is supposed to be something else, something more prosaic. Every day.
The pen and ink.
Look down. Look down.
Bread and butter.
Do you have bread? Can you see bread when you are looking down?
He's
Look down
eating.
now. Those of whom who are sitting in a chair, just look down. What can you see?
So floor.
You see your feet, and given
Yes,
that
sir.
it's winter,
Yes, sir, feet and shoes.
Feet and shoes. Feet and socks.
Socks, sir,
no,
socks.
not socks. Right
Slippers.
shoe, or well, slippers. So right slippers and left slippers. That is supposed to be
Yes,
the
sir.
best example.
Yes, sir.
If I give,
So that we can't buy them separately.
yeah, you can't buy them. That is why you can't buy them separately. They are perfect complements. So, I mean, those of us, you know, that we have to go to the mosque to pray on Fridays, and also on Eid and Bakrid.
Jumma,
So,
sir.
Jummah. So the problem is that in some places, people may take away your slippers. If you have got very nice shoes, there's a risk that some people will envy your shoes and take them away. So do you know what the best way of preventing this is? You keep one shoe
Wearing
on one side and keep the other shoe
Keeping
far
one
away.
shoe. Yes, sir. Yes, sir.
So in that case, you can keep your shoes safely. Okay. But the theorem, but if you haven't done price substitution effect, okay, I think it's better if I do this theorem later on. And anyway, I'm sure that you're very tired, so I'll come back and discuss this theorem later on. Right now, I will just state the theorems to you. There are two theorems, the two commodity case. In a two commodity world, both commodities are substitutes. And the general form, the generalization of this statement, of this theorem, in an n-commodity world, all goods cannot be complements. You will have at least one substitute, if not more. So you can prove this very simply using Euler's theorem. But before that, I need some results which MD will discuss. Okay, so I'll stop at this point.